Welcome to this 10-minute lightning talk exploring the U.S. National Bridge Index presented by Michael McKinsey. You can start now, Michael.
Can I just verify you guys can hear me?
We can hear you.
Perfect.
Thank you.
All right, great. Well, thanks, guys. My name is Michael McKinsey. I have a master's degree in civil structural engineering, and I'm going to talk to you today about one of my personal passion projects that involves exploring the U.S. National Bridge Index. Well, the first off is the question of why we'd want to even look into something like this. Well, back in August 1st, 2007, the I-35W bridge in Minneapolis, Minnesota reached national headlines for experiencing a complete and utter catastrophic structural failure during rush hour, leaving behind a quite devastating scene. At the time, I was in my undergrad doing applied mathematics, and something about this stuck with me because in my time, I had never seen a structure collapse without some sort of external source, whether it be natural disaster, an impact, and it kind of just ended up in the back of my brain for a while. Fast forward into grad school, and while there, I came across the National Bridge Index data. This is a series of data that has files from 1992 to from when they started it all the way up to 2018. The data includes information on the bridges in all 50 states, also includes Washington, D.C. and Puerto Rico. There's actually a larger set of data on the site, but I haven't gotten into that just yet. But my talk today is going to be revolving around the 172 files that are accessible via direct streaming from the national site. About 468 of those are delimited files. There's 1,400 that are not delimited. Combining all of these files, that turns out to be about 23.6 million rows of information, with each row containing 122 properties that relate to something about the bridge. And I had had this for quite some time and never really knew how to approach it until I came across Neo4j. So here's an example of what one of the files looks like. It's a series of numbers, letters, all just kind of put together into one massive file. Well, luckily, the NBI provides a resource that explains how to decode the data. So for 122 of these properties, you have to go through this document, change the encoding, break it out, and identify what it looks like. So, but the first thing is to identify what each aspect of it represents. So going back to what we just looked at with our data, you can see that in each one of these lines, we start to break out individual components that contain some sort of contextual information, but everything is given some sort of code. There are certain areas that have text, such as like the Chippewa River, but everything else is given some sort of value of a combination of numbers and or letters. So using that idea and going along with the encoding, the problem is, how do we make use of this information? Because you have a series of files, and in each file, you have a series of rows. Well, each file is going to be connected to a state. Each state has a county. Each county has a place or a city or a town. And then in each place, you're going to have some bridge that's connected. So as stated before, the file represents information about a particular state on a given year. And then each row represents information about a bridge. Well, that looks like a graph to me. And that's where the Neo4j graph database really kind of brought this project to life. So we can kind of see how this simple problem becomes a more like a graph structure, where you have a file that contains a row. The row is data for a bridge. That file is for a state. And then all of the other relationships shown relate to additional contextual information extracted from it. Now, at the moment, you'll see that there's a dashed line that extends from the bridge up to the state. and then a red relationship from a bridge to the place. At the moment, I discovered that there's some sort of anomaly where we're getting bridges connected to places that they shouldn't be. So I went ahead and I just connected bridges directly to the state as a temporary bypass of that situation. But in general, you've created a tree-like structure branching out from state to county to place to bridge. And we translate that over to our Neo4j graph model, and that's essentially what you get. The red oval identifies that missing of place relationship. Now, two of the relationships that I find interesting, and will come up here in a second, let me click back, is the relationship between states. So there's a self-related relationship called borders. So I was able to find additional information to where I could find out what states border which states. And then extracting the encoded information, I discovered that there's a column that represents bridges that are shared between different states. So what does it look like when we take a look at when we take a look at the relationship between states? Well, here's what we get. So this is simply a query that returns all of the relationships of the states and the borders relationship between them. Now, at first, this seems like, okay, that makes kind of sense. It looks like the United States, as one would expect. But you combine the idea of looking at a bordered state with a shared bridge, and you start to open up the possibility of asking questions that may not have been prevalent looking at the data when you're looking at each file separately. So the next query here is going to show a relationship of some of the bridges that exist between each state. So you'll see that the blue represents states, and then each green, there's a pair of them, represents bridges that are shared between those two states. And the reason there's two nodes is that each state has its own file, and each file has its own bridge identifier. So the two different state files have their own bridge identifier, and then in that file, it relates to the opposing state's bridge identifier. And so we can start to connect some information and get some contextual ideas of next steps and questions that we would like to ask. So where I'm currently at in this whole process is I am in the process of looking at building a GRANDstack application. I do have a prototype up and running. I won't do a demo just for the limited time that we have at the moment. But here's like an example snapshot of the GRANDstack application that I've been building. One of the reasons why I really wanted to build something was bridges represent a geospatial entity. They exist on graphs, on the planet. And how can we gain additional context unless we can see it? And you can kind of see here some examples. So what I have in this image shows the states and locations that I've lived. I have a query that just ran in and plotted some data points. And you have these outliers that seem to exist like in the middle of Pacific Ocean and over in the middle of the Atlantic Ocean. And that's information that wouldn't necessarily be easily identifiable if I couldn't extract that information out and start to plot it on a map. So right now, this is just the first step, is let's take the data and let's plot it on a map for the ability to interact. Well, what comes next? Well, decode, decode, decode. I've only touched about 10 or 15 of the 122 properties. Each one requires its own decoding of going through the document and trying to gain additional contextual information based upon what's stored in those files. Additionally, and this is something I've learned recently, is I want to create some sort of audit record or some sort of log of how properties change over time based upon the files. Now, this is obviously something that's very easy to do because of the flexible nature that Neo4j offers. Is as I come up with new ideas or as I need to add new information, I can modify the schema and add that contextual information. And I believe that that's a good way to make this easier for us to track what's going on and how we can improve it. And then along with that is just to continue adding the properties that exist. Now, what are some of the end goals that I have for this? Predictive analytics, as I stated kind of towards the beginning, that the national infrastructure in the United States has been deemed to be in a fairly rough spot. And it would be nice to provide some additional insight to try and identify places where we could focus on making improvements. And along with that is it possible to create budgets and provide additional context to help make adequate decisions so that when we identify what bridge is in trouble, we can adequately fund the repairs to said bridge. And then that also goes on to here is it's not even just about providing funding, but can we even go a step further and make active recommendations based upon maybe funding constraints? And there's a lot of flexibility and opportunity to kind of capitalize on. So a quick thing about me, I know 10 minutes flies by pretty fast. I'm currently a programmer here, Caliber in Alexandria, Virginia. I'm also the Graph DBDC organizer here in the Washington, DC area. I'm always looking for people interested. I love learning about people. Feel free to reach out and contact me via the web, LinkedIn, GitHub, all the good places. And I really appreciate your time. And then I believe the next slide is going to be the Hunger Games. So I can read these out. So the first question is, when did the I-35W bridge collapse? Was it A, October 10th, 2019, July 4th, 1776, or August 1st, 2007? The next question is, what two places are included in the NBI files other than the 50 states of the United States? Is it A, Washington, D.C. and Puerto Rico, B, Washington, D.C. and Bermuda, or is it C, Puerto Rico and Bermuda? And then the last question is, what does NBI stand for? And if anybody has any questions, I think I've got a few minutes, but pretty tight here. Any bridges to be really scared of? That's a difficult question. I think I'm at the point now with where I'm at in the data. That's not really something that's easy to identify just yet. There's a lot of additional context that to explore with what it is, what's stored there. If anybody's interested in also working on this, be sure to reach out with me. This is something that is, everything I've done so far has been a solo effort, and there's a lot of data. I think I'm at 25 gigabytes of data easily so far in the graph without anything else.
Very impressive, Michael.
Thank you. I appreciate it.
Does anybody have any other questions? All right. Well, thank you very much for your presentation. It was great.
Awesome. Thank you guys, and enjoy the rest of the conference.
Thank you.
Bye.
Bye-bye.